Hi there. Happy Distance Learning Day. We are going to go to slide 7 and learn about slope today. You've probably calculated slope in your math class before, and you'll see that over here to the right, the equation for slope is given to you. Slope is your rise over your run, or you could pick 2 points and find the difference in y divided by the difference in x. We're going to practice that for question number 1 together right now. Question number 1 asks us to calculate the slope of the line on this graph. And so we pick any 2 places that are easy for us to read off the graph. A good place to be would be like the very first point and the very last point. If those are easy for you to read, those are good places. When you're trying to find that slope, you can either say that this is point 1 and this is point 2. And when you do that, you would write like x1, comma y1, and x2, comma y2. And so that would be that x1 here is 0, and y1 is 20. And for the second point, x2 is 10, and y2 is 0. And then you could follow that equation. That slope is equal to y2 minus y1 over x2 minus x1. So in this case, that would be 0 minus 20 over 10 minus 0. And so when we're calculating that, we would get 0 minus 20 is negative 20, and we would have 10 minus 0 is 10. And so negative 20 divided by 10 is negative 2. Now you're used to just only having number values for your slope, but it turns out in physics, our slopes have units attached to them too. Notice how this y-axis right here had units of meters. Notice how this x-axis right here had units of seconds. Well, when you take your y value of 20 meters and you divide it by your x value of 10 seconds, the units for your slope are going to be your y units of meters divided by your x units of seconds. So because slope is y over x, the units for your slope are your y units divided by your x units. So the units for these slope right here, if it's a position versus time graph, you're going to take meters and seconds, and you're going to say that your slope has units of meters per second, which is how we measure velocity. Velocity tells us how many meters we go per second. That means, going down to question 3, the slope of a position time graph has unit of meters per second, which means it tells us the velocity. That means the velocity of that object for number 1 was negative 2 meters per second. That was the value for the velocity. It told me how fast, 2 meters per second, which way? Negative direction. However, if we look down to question number 4 and 5, if you have a velocity time graph, notice how the units for velocity are meters per second. So your y-axis has units of meters per second, and your x-axis has units of seconds. So when you're trying to find the slope of a velocity versus time graph, because slope is equal to your change in y divided by your change in x, the units for your slope, again, are your y units divided by your x units. And so the y units are meters per second, and the x units are seconds. That means the slope of this graph is a meter per second per second. That is not a velocity measurement. The unit for this velocity time graph, meters per second, is actually a unit that we measure acceleration in. Remember, acceleration is how our velocity changes. And so it's telling us how many meters per second our velocity changes by per second. So for question number 5 here, when it asks us to solve for the acceleration of the object at 5 seconds, we would look at 5 seconds on the graph. We would go up to 5 seconds, and we would say, I need to find the slope of this graph. I'm going to take that point right there and another point that's on that same line segment A. And what I'm really asking you is to find the slope of line segment A. And so when I'm finding that slope of line segment A, I can pick these 2 points right here. Say this is point 1 and this is point 2. And I could do that exact same process I did before. x1, y1, x2, y2. The other way of looking at slope is to say that slope is equal to a rise over a run. The rise is how much it goes up. It went up from 1 all the way up to 3. And so that rise right there is up 2. The rise of this graph is positive 2. The run of this graph would be how far it went left and right. And it looks like it's just 2 boxes. But if you read this off, it goes from 15 to 25. So you have to be careful when you're doing rise over run. You can't count boxes. But you can say it went up from 1 to 3. So it went up 2. And went it over from 5 to 25. So that's a run from 5 to 25 of 20. So I went up 2 meters per second in a time of 20 seconds. So I'm going to say that I have plus 2 meters per second over a time of 20 seconds. So the answer for my acceleration right there would be 2/20ths, which is 1/10 or 0.1. And the unit would be meters per second per second. Because again, that's our unit for acceleration. If I was asking for the velocity at 5 seconds, the velocity from a velocity time graph, that's a little tricky. The velocity at 5 seconds, I would just look at the y-axis. The y-axis is telling me my velocity is 1. So my velocity is 1 meter per second. Whenever they ask for velocity, the unit should be meters per second. Whenever they ask for acceleration, the unit should be meters per second per second. Try this out. You can type your answers into the boxes here. And so if you use the text tool to type your answers into the boxes, you should be able to tap, actually not the text tool, it's the arrow tool. And so if you type your answer in, it'll tell you if you got that answer right or wrong by turning green or turning red when you type your answers in. And so we can look to see if we're doing it right that way. Or we could also just write it down and check it on the key on Schoology. All right, now you can do this slide and you can do CP5. Remember, you have to have a 4 or better on CP5 in order to earn attendance today. Feel free to email with any questions. Good luck.